Hello, my name is Rob Reynolds. Welcome to Calculus section 3.1. Today we get the introduction of a derivative. And when you hear the word derivative, I want you to think the slope of the tangent line. Can't pass calculus without knowing the definition of derivative. Half of the course is derivative. The other half of the course is going to be integral, which is the antiderivative. So the slope of the tangent line, and tangent simply means that it crosses the function at one point. You can see here the slope is positive. And over here, the slope of the tangent line is negative. We're going to be using some formulas and definitions to try to be a little bit more accurate to find out exactly the values of those slopes of tangent lines. But you can see that the slope keeps changing. And then, of course, a really important definition is when that slope equals 0. You either hit a max, or if the slope equals 0, you could have hit a min. So it's one way that we can analyze a graph. So again, the secant line is something that does not cross once. If this is the x and the y, and this is a parabola, here's the secant line. I'll make it in red. Notice the secant line's definition is intersects at 2 points. So what happens is if I move those 2 points closer and closer and closer together, you can see that here the 2 points are much closer together than they were before. So as I decrease, or as I approach this distance, we'll call that delta x, that distance, that change of x distance. Right here is delta x, the change of x. As that gets smaller and smaller, and that's where limits come in, and I get it virtually approaching 0, then the secant pushed to the limit becomes the tangent. So the secant is nothing more than the slope between 2 points, and we know how to do that. It's just y minus y over x minus x. And we have fancy words for y, sometimes the function f of x, and then another y might be f at some specific a value or x value, and then x minus x. So you can see this is just slope. That's how you find slope between 2 points always. But if I take that definition and then push the limit as x goes to 0, or delta x goes to 0, then of the slope, then that means I've located the tangent slope of this, where it only crosses once. So when you're finding the equation of a line, you could use this formula. Y minus y is equal to slope x minus x. Most calc teachers and most textbooks actually teach that. I learned from my calc teacher to go to y equals mx plus b. So you're welcome to use point slope form. This is what my math lab will use. This is what your textbook teaches. But again, I learned it just to plug in for y equals mx plus b, because you kind of want your final answer to be in slope intercept form anyways. Let me give you an example. Here's a function, and they gave me some points, or more to the point, 1 x and y ordered pair. So if you let x be 1, y will be 80. So we're going to use find the slope formula by taking the limit and pushing x close to 1, because that's our x value. So we want to find the slope at that particular point. So I'm going to use the f of x minus f of a, where a is a particular x value, all over x minus a, and a equals 1. Remember, the function is this negative 16, x squared plus 96x. Minus f of 1, let's go evaluate the function at 1. Well, I don't have to do much work. It's given for me. It's 80. That's the point that they gave me, all over x minus 1. So then I'll use some algebra skills and try to factor this thing. I think the greatest common factor is 16, leaving you with x squared minus 6x plus 5, which factors some more. Negative 16 times the quantity x minus 1, x minus 5, over x minus 1. Remember, you got the limit out there. You should drag that along every time. But when I cancel this out, then you can see I'm really just going to evaluate the limit as x approaches 1 for negative 16 x minus 5. And if I plug that in correctly, I will get negative 16 times negative 4, or a whopping 64. So now I found the slope. So let's go write the equation. And again, you can go to y minus y is equal to slope x minus x equals mx plus b. And we were given an x and a y value. So here up here, x was 1 and y is 80. So I'm going to plug that in down here and say 80 is equal to my slope, which was, we found 64 times 1 plus b. And then the y-intercept turns out to be 16. And the final answer, the slope of the tangent line equation, is y equals the slope 64x plus 16. And here is the book's solution. And they even give a nice little graph. You can see they graphed the line 64x plus 16, and there's the function, and there's the point that it's tangent to. This is just demonstrating the secant line. As you push the secant line to the limit, you'll get the tangent line. So again, the secant line, 2 points. The tangent line is just the limit. But notice the definitions are exactly the same. The only difference is you're just pushing those 2 points infinitely close together, and that's the limit definition. Which by the way, we'll learn that's also then the derivative at a, because that's what this chapter is about, the introduction of the derivative. So when I say the derivative, that means I'm finding the slope of the tangent line. Here comes the second example, which gets a little bit complicated because we have to FOIL out a quantity cubed. Let me show you how to do this. Let's see. F of x plus h minus f of a all over h. And you may say, well, wait a minute. Well, I thought the definition was f of x minus f of a all over x minus a. And where's all this h business coming from? The answer is on the slide that I kind of skipped past, but you can see if I define this point as a comma f at a, and let this distance be delta x, which we're going to be simplifying delta x as just being a change. It means the change in x. So if this was a 5 and this was a 7, delta x would be 2. We'll just let that be h just to simplify the formula a little bit more. Then this point here would be f of a plus h minus f of a plus h, because we're just adding the h, or the delta distance, minus the y value, which is f at a, all over, well, remember, all I'm doing is finding slope. So I'm doing the y minus y over x minus x. And so here's the first y value, the f at a plus h, and the second y value is right here. So here's an x, and here's the y value for this point, and then here's, oh, I'll call that x sub 2 and y sub 2. So I'm doing y sub 2 minus y sub 1, and there's y sub 1, which is okay. And now I'm ready to do x sub 2, which is a plus h minus x sub 1, which is this a value. And that's what leaves me with just an h down below. So that's how we get this definition. You're going to say, well, which definition do I use? And I'm going to say it doesn't really matter. I don't really use this definition a whole lot, but I'll show you it to you. My recommendation is, now that I've given you like 3 or 4 definitions of derivatives, is I always use the same one, f of x plus h minus f of x all over h, as the limit as h approaches 0. So we'll get to that in a moment. But I like this one because it's just general. This one only finds you the slope at the particular point A, where this one will find me something called the slope formula at any given point. So this says go to the f function and plug in an x plus h. So instead of x cubed, I'm going to say x plus h cubed, and that's where that gets a little bit difficult, multiplying that out, plus 4 times the x plus h minus f at a. Well, its a is 1, so I want to find out what the function is evaluated at 1, and that's 1 cubed plus 4, or 5. all over some h value as the limit as h goes to 0. So the mistake would be to try to distribute this, which you cannot. You can only distribute exponents over multiplication and division. So you need to multiply it out, and there's something called Pascal's triangle that would really help for you to quickly multiply it out. So here's Pascal's triangle. 1, you add these two numbers, 4, 6, 4, 1, and you can continue. But this is the row that I'm interested in, this 1, 3, 3, 1. Those are the coefficients of this guy getting multiplied out. 1, 3, 3, 1. And then you kind of think about cubing the first term, x cubed, and then walking that down, x squared, x and no x's, and then the h starts at 0. I could write h as 0, but there's no reason to. Then h of 1, h of 2, and then h of 3. And that's the fast way to multiply that out. There's some more in here, plus 4x plus 4h, excuse me, hit a wrong button, minus 5, all over h, and remember you got the limit as h approaches 0. So the goal is, you can't do direct substitution because that would divide by 0. So the goal is, let's see if anything cancels. Just realized that I was mixing up as I was explaining this f of x plus h. I've rewritten this wrong. This should have been a plus h because I'm doing f at a. So the formula says f of a plus h, not x plus h minus f of a. So if I were to go back, and I know a is 1, this is a 1 plus h, this is a 1 plus h, and that gives this x value a 1 cubed. So this is really just 1 plus, because now I can just let ax equal 1. If I let x be 1 through this thing, which it says I should be letting x be 1, it's given as the a value, then this guy goes to just 3h plus 3h squared, because I just have x to be 1, plus h cubed plus 4 minus, because this is a 4, this is a minus 5, which gives me a minus 1 plus 4h. And there's what I was looking for. It looks now that this 1 and this 1 is going to cancel. I'm left with all the terms with h's in it, so I can factor out an h, and this should always happen. This is why I knew I was stuck in the water, because the goal is to factor out the h's so I can evaluate the function at 0. So if I factor out an h from all of these terms, I'm left with just 3. Well, why don't we factor out and combine a little bit here, because I've got a 3h and a 4h. If I factor out the h, that's gone, but now I don't have a 3, I have a 7. So 7 plus 3 h's, if I factor out an h from this, plus h squared. And then I'll try to just evaluate the limit as h goes to 0 of h squared plus 3h plus 7. And if I let h be 0, I get 7. So trying to write the equation on the line, y equals mx plus b. I need to pick a y value. Well, they didn't give it to me. They only gave me x, but I think I found out that the y value, there it is, y is 5. So I'll say 5 is equal to the slope 7 times the x value, which was a 1, plus b, and I come up with b is equal to -2. So the final answer here is y is equal to 7x minus 2 for the slope of the tangent line. And again, the author might have worked this out a little bit better because they actually plugged in a 1 from the beginning, and I did not. So they were showing you how to expand that from the get-go. So next couple of slides starts talking about the instantaneous rate. And whenever you see rate of change, you should think slope. And now when you see slope, I want you to think the slope of the tangent line is simply the derivative at some point 8. So whenever you see instantaneous rate of change, that's kind of physics talk for find the derivative or find the slope of the tangent line. That's going to be the velocity of the function, the rate. And again, the preferred definition that I just always use, I don't use any of these other definitions. I don't ever use a but you might have to in my math lab. But I just always use f of x plus h minus f of x all over h to find the derivative. So when I say use on your test, I'll say use the limit process, and that's how you'll know that you need to show me all this work. Now, later in the chapter, we'll find out how to quickly find the derivative of this, and maybe if you've had calculus before, or sometimes in pre-calculus, they even show you a little bit of derivative work, but you can't use that here in this section 3.1. 3.1 is all about the limit process. So if you know a cheat method or a faster way to find the derivative, you can use it on your homework, but we'll wait till section 3.2 and 3.3, and we'll be experts at the shortcut method. But 3.1, I would practice, because I want to see it on the test, the limit process. So even though the directions don't say use the limit process for this, we only know one way to find the limit, and that's to use the f of x plus h minus f of x all over h, and then push that limit or the distance between x to 0. So let's try that. Go to the function and plug in x plus h. Negative 16 x plus h quantity squared plus 96 x plus h. So that's the first part of the definition. F of x plus h is all of that. Then I'm ready for minus, let's do that a different color, minus the green. So in fact, sometimes I even like to put parentheses around that so you don't forget to distribute this negative after you write down the function. So the function is this negative 16 x squared plus 96x. And of course, it's all divided by h, and we've got the limit out here as h approaches 0. So distributing and combining like terms, remember this is that square double square rule. So we square the first, twice the product, square the last, and then I'll even distribute that 16 to all three terms. This is really negative 16x squared minus 32xh minus 16h squared plus 96x, 96h. So if I distribute this negative, this becomes plus 16x squared minus 96x. And then all of a sudden, I think I did something right because I see a bunch of things canceling. If a bunch of things don't cancel, then I would start wondering if I didn't make a mistake somewhere. So those 16x's are gone. The 96 is gone. And all the terms that are left have an h in it, like this should always happen. That can be factored out. So I'll factor out that h. So it will cancel with this h, so I can do some direct substitution. So if I factor out an h, I'm left with negative 32x minus 16h plus 96, which now I can evaluate, throw in a 0 every time you see an h, and I'm left with just negative 32x plus 96. And you're going to say, well, wait a minute, that doesn't look like slope. But again, since I use the general formula, this is really powerful. This will find you the slope of the tangent at any given x value. All I have to do is know what x value I'm looking for. So we call this the slope formula for anything. So if x was 1, I would just let x be 1 and then find the slope at that 1. So this function is a parabola facing down, and it's got many slopes along the way. And so I might be interested in more than one slope, and so this formula will let me quickly evaluate the slope at any given x value. So, and again, one of the things that I'm really interested in is when that slope hits 0, because later we'll talk about maxes and mins. Stop the video right there and create another video to kind of finish 3.1. It's kind of a longer lesson. We'll kind of start on this slide where I'm talking about the differences, ways to write the derivative of the function, or y prime. And so we'll start right kind of on this slide, and I'll end this video. It's been going about 20 minutes, so I'll create another 20-minute video, hopefully, for finishing up section 3.1. If you have any questions, feel free to email me. Thanks.